All right, welcome back. We are Game 3001 in the winter 2022 semester at George Brown, and it's week 9, part 2 of our broadcast and time together. And this week we're talking about decision making, and decision trees, specifically. We also talked about how last time we were together we were really talking about A-star pathfinding. Gave you some feedback on A2 in the lecture, and A1. As well as this week, we fully talked about decision trees. I also opened up assignment 3 and assignment 4, which kind of one assignment depends on the other one. And what this lab and all the labs do is help us build the assignments, but it doesn't tell you everything. It doesn't give you everything. Some of the stuff you have to do is on your own. So again, we're starting with, we're at lab week 9 and we're doing lab 6. And the first part of lab 6 is a 2-parter that starts this week and finishes next week. Okay, let's take a look at some of those high level goals we talked about. Well, we definitely want to clean up the placing and remove tile and grid references, remove GUI UI elements, and we want to review line of sight and how that works because it's fundamental to both A3 and A4. We'll be using line-line intersection tests and line-rect intersection tests for primitive raycasting. We're going to be setting up a PathNode class, which is replacing the tile class, and a grid of PathNodes, which replaces the grid of tiles. And GUI is going to be used to show and hide PathNodes. There's the little blue squares that we're going to have, as well as we're going to add obstacles, and the obstacles are going to help us kind of work with line of sight to show how line of sight works with the target. So that is our lab 6 high level goal. Alex has come to us and added some additional notes, and I like a lot of the stuff that Alex did this time around. He was really innovative with some of the changes he made, and we're probably going to incorporate some of these things into our framework going forward. So some of the stuff that he's asked us to do is we're going to start with our lab 5 finished project and go to lab 6, and we're going to overwrite some of the source files attached to the lab 6 item. So that lab 6 item has several source files, collision manager, util, and texture manager. Alex has updated, and what we're going to do is we're going to take some of these items and override our project. So let's start off with that. So we're going to say, again, go into desktop. We're going to go to GBC. We're going to get into this one and go to section 400 where we have lab 5. I'm going to copy paste lab 5 into lab 6. And I encourage you guys to do the same. Okay, there's lab 6. And in lab 6, in the source folder, this is where the changes are going to go. What I've done in prep to this is in my downloads folder, I have a lab 6 sandbox where I have all the files that need to be replaced. So again, I'm grabbing all these files from lab 6's item list. I'm going to grab all these things right here. That's what I downloaded, copy them, and then go back into the desktop where I have lab 6's source files and paste them. It's going to ask me to replace them, and I'm going to do that right away before I do anything else. So that's been done. Okay, so that's what he's asked us to do, and we've done that. It says this will save time. He's just added additional functions for us, and I think there's some great things we're going to talk about in our lab today. Let's put this up on GitHub. So we're going to say, again, I'm going to pull up GitHub desktop. And there it is. And what I want to do, of course, is target section 401, section 400. That'll be okay. And we're going to say added lab 6 project files. There we go. Lab 6 project files. This is with no changes. This is just me adding stuff to the project, just like Alex has asked. And it's taking time to, commit all those changes. 964 changes have been made, and we're committing those things. You can see a lot of little changes pushed to origin, and so we're pushing all those changes up. Awesome. That's fantastic. Just copied and pasted the text into the old cpp.h files. Will that work? Yes, it will. I would rather just replace them to make sure that you don't make any copy-paste errors, but that's just me. So that's what I do. but it's on you how you want to do it. I'm going to launch our template just like we've done in the past, right? And first thing I always do is I always test to see if our stuff is still working with the changes that we just downloaded. All right, so let's just get rid of this. So I'm going to kind of right click and close all tabs, and making sure that this x86, I may have to check it to make sure that it's okay. First thing I want to do. So let's make sure that we're like for like, and whatever we had last time is still good this time. Because if it's not, then anything we try and do after this is going to be all broken. We don't want that to happen. Hopefully that makes sense to you. All right, so we're starting off and we're going to go here. We're going to toggle the grid. We can see this. We have our obstacle that we put in there, and we have one little obstacle. We're going to use Euclidean distance, find shortest path, and it finds the shortest path around that obstacle. We can start pathfinding, and it's going to do that stuff. This is all the stuff that we did last day. Right? Nice. Excellent. All right, so what does Alex tell us to do? Because we're going to follow Alex's plan. He's saying, okay, in the spaceship.cpp in the constructor, add some lines for heading, direction, and line of sight color. So that's the first part that we're going to do. Let's start working with the spaceship.cpp as we modify stuff. So again, into game objects, spaceship.cpp. We're going to pull this up, and previously what we had was a height and width of our spaceship, and we had a position. We're not going to put the position here. Let's take that out this time around. And we're going to have bounds, velocity, acceleration, and is colliding, but we also need some information about our heading. So set current heading. Remember, this is from our steering behavior days, right? And we're going to start our heading at 0, 0. We're also going to set our current direction, our set current direction as a GLM vec2 object, which is 1 and 0, which means that it's pointing to the right, right? So this is a right facing, and an angle of, this is our current facing angle. Okay, so the rest, acceleration and all this kind of stuff is going to stay as is, right? One thing we also want to set up ahead of time is our set line of sight distance. The line of sight distance we're going to extend to 400 pixels. So that's like 5 pixels per frame times 80 feet, which is our 5 pixels per feet times 80 feet, right? As an example is 400. That's how that's the distance is. We're setting up almost like a ratio, right, of our of our map, kind of setting up the size. And we're also going to, back 4, change the color to red starting off by default. So the ship doesn't have line of sight starting off. So our default line of sight color is red. Okay, so that's where it starts off. So this is where it is. We know that the ship is an agent type, and this is the first piece that we're going to change. So this is cool. In our draw function, right now we have drawing the ship, but we also want to draw the color. So we're going to say, let's draw line of sight as well, which is basically a sight line that goes from, from the ship across. We're going to say util, draw line, and we're going to say get transform dot position, and that's where it starts, and the end is get transform dot position plus the get current direction, whatever direction we're looking at, which is to the right now, multiplied by the get line of sight distance, so that's 400 pixels, and then we're going to use our line of sight color, which is going to start off as red. Okay, so that is the draw line of sight function. Okay, so that's all we've done so far to the ship. And pretty much we're going to leave everything else identical. We're not changing the ship beyond this. Let's test it and make sure that this thing is working. And what we're going to see is a line of sight that's being drawn from the ship when we're in debug mode. Let's try this out. So actually we're here and there's the line of sight. Yay, right? Cool. And again, the grid looks like a grid still because we're still doing this. We're working at it, but the first thing is we've drawn a line of sight, a little red line that goes from the ship outwards. Okay, you should have that. And that is this part. So spaceship, draw a line of sight, and then we have our agent class already. So now this is good. Let's put this up on GitHub. So we'll say that added ship line of sight, which is kind of what we did, and push to origin. Nice. Next part is the obstacle. So obstacle.cpp, in the draw, we're going to invoke the overridden draw of a texture manager and this as the fourth parameter. Let's talk about what that is and why Alex has chosen to do that, which is kind of a neat thing. So let's do that. So again, let's close down ship. Ship is done. Let's go to obstacle.cpp, which is what we're going to be using this time around. Tarif says, why is it 400 pixels for line of sight instead of a whole screen? Because we want to limit how far the ship can see. That's why. We want to test it so that we only have a certain range for the ship, but you certainly could make it farther. All right, so in the obstacle itself, right? So right now, my obstacle has a, we define an obstacle in the texture manager, what it is. We get X and Y coordinates. We started off at 300 and 300. That's where the obstacle starts off at. It doesn't really matter, right? Because we're going to reset this position anyway. We set the obstacle as an obstacle type. And then in the draw function right now, what we do is we use the standard draw function, which takes the X and Y positions of the obstacle itself, the angle, the alpha transparency, and if it's centered or not. What Alex has done, if I go to definition for this thing, go to, oops, I could have done that, but I meant to go to definition. Let's try that again. Go to definition, not peak. Then notice that this is our standard function for drawing. What Alex has done is he's made another draw function. And this other draw function, what it does is it not only takes the all the stuff I said, but in addition, it also takes the game object itself. So why? Because if we send in a different width or height, then what it does is it allows us to draw the object or modify the scale of the obstacle, right, or whatever that game object is, to whatever the width and height that we've posted is. That's what we're doing. So if the width and height are different, as an example, than the bounds, right, then that's okay. What that's going to do is it's actually going to use the width and height to scale the object. Okay, so that's what it does. It creates a, the destination rect W width and height is going to be the game object's width and height. That's what we're going to be doing. So a different way of doing things than what we've done before. Here, that's not how it works. The destination width and height is going to be the exact size as the texture width and height, right? So here we're allowing this to be modified so we can change the width and height depending on what we pass into the, what object we pass in. So then, going back to our texture manager instance draw obstacle, start off in X and Y, and we're going to pass in a reference to this, which is this game object itself. 0 is the angle, and we're going to change our alpha transparency to 128, which is going to make it partially transparent. Yay, awesome. That's our obstacle. And that's what he's asked us to do here. You can see that he's asked to do that and push this up on GitHub. So again, going to here, we're going to say modified obstacle to use new draw function. Okay, so commit to main and push. All right, that's that part. Next part, let's get into the, let's get into the next part. So, okay, PathNode, this is where we need to do a little bit of work, but not a lot. You're going to see that there's not a lot in here yet. We're going to put more into that later on. So we close down the obstacle, and we want to make a PathNode class for both the CPP and the H file. So let's do that in game objects. Just like we had the tile node, the tile class, we're going to have a PathNode. So we're going to have a new item, and we're going to call this the PathNode or PathNode.h. And we don't want to put it in the template. We want to target, remember, we want to go up to the SRC folder. You can also type it in yourself. And that is where PathNode.h is going to live. Add that in. And we're also going to do the same thing right away a new item for our PathNode.cpp, PathNode.cpp, again in the src folder, add that in. And in our PathNode.cpp, we're going to make a reference to our PathNode.h. Okay, just immediately let's get that done. And this makes a linkage between PathNode.h and PathNode.cpp. In PathNode.h, what we want to say is if not defined PathNode, we want to define PathNode. And we're going to say indiff. Okay? And we're going to say defined PathNode. Okay, all the same stuff we've seen before. In here, we're going to say a new class called PathNode. That's the first part of PathNode. And remember what the PathNode is going to be. It's going to be an agent, a public agent. And we don't have agent defined, but we can include it here, right, as we normally do. We're going to have two parts of the PathNode class, a public area and a private area. The private area is going to be pretty empty right now. But we're going to need a couple of things in the private area. A constructor function, right? We're also going to need a destructor function. And also some lifecycle functions. Okay? Those are the things we're going to need. So, so what does that look like? Well, this is the PathNode. This is where all the work is going to be done in the PathNode constructor. In the destructor, we're just going to make it so that it just is the default constructor. In a second, we're going to do that. And then the lifecycle function is pretty simple to get those done. All we have to do is go to PathNode, the PathNode class, and go to the little hammer and just say generate missing members. It's going to add in the draw, update, and clean functions. Nice, nice, nice. And that's our .h. Pretty simple. Okay. So again, all I've really done is we've kept all the basics here, and we're going to put everything inside the PathNode constructor. I'm just going to copy paste that inside of our chat. So if you need that, you can move on with this. Next, let's get into the PathNode.cpp. Here's our PathNode.cpp. And here, and again, like I said, what we want to do is we want to generate definitions by declaration. So here, click onto that, go to the little light bulb, generate definitions by declarations, and press finish. And inside of our PathNode destructor, we want to say that's equal to default. And so we're going to do some work here and in the draw function. Let's do the draw function first, actually. And Alex has added a couple of things we can draw rect, but he's overloaded the draw rect function in our util. That's another thing he's done. So we'll say util draw rect. Hey, let's add that util class in here to our reference, right? So we want to draw rect, and there's a couple of overloaded options here. So if I open this up, you can see that draw rect needs a position, width, height, color, and so on. And what we're going to do is going to pass in a couple of things here. We're going to say that, hey, get transform dot position and minus a GLM vec2 that is 5 by 5. This is going to take our starting position. Remember, our little path node is going to be like a 10 by 10 little square, right? So this is going to count backwards to the left and up to the left, top left corner. And then we're going to say get width and get height. And we're going to use a get line of sight color, which we'll see what that is right now. We don't know what that is yet. So that is our little draw function. In the PathNode constructor, this is where all the fun happens. We're going to set our width to 10, right? And we're going to set height also to 10. So our little path node is going to be a little 10 by 10 block. That's what it's going to be. We're going to get transform dot position. We're going to set our position up to be an empty GLM vec2 object, which is 0 and 0. And then we're going to get our rigid body, and we're going to say that initially, it's not colliding. Is colliding is equal to false. So there's no collision with this path node. We're going to set the type of the object to path node, and actually it's been path node as a type has been here from the very beginning. We just never used it. Then we're going to set current heading. For now, our current heading is going to look to the right. Again, this is just to set up our initialization. And set current direction, again, is going to be looking to the right. We probably could have copied this from the spaceship, but why bother? Because it's really simple to do. All right, so this is kind of looking toward the right. And again, something like we did before, facing right. I mean, can PathNodes really face right? Not yet. And then we want to set line of sight distance to 1,000. So again, this is a little bit longer. Again, we're going to get back to using set line of sight distance. This is the whole screen, because what we want to do is have each path node, can each path node see every other path node? Or can each path node see the target, right? And then we're going to set our line of sight color as GLM vec4. So what is the color of our little object? It's going to be 0, 0.5, and 1, where that is really kind of a light blue color. So this is a light blue color, light blue color. That's what it is. And that is our path node. Okay. So what am I doing with this? Well, what I want to do is on my screen, just to give you a sense of this, here's my screen. And oops, that's the color. But no, my screen is going to be black starting off. Let's say this is my screen viewport, right? And then what I want is for a bunch of these path nodes, let's make it a little darker, a bunch of these path nodes to be around. So let's say, for example, I'm going to put in the same number of path nodes that I had put in before. So remember we had a bunch of tiles, right? And we're going to have a bunch of these path nodes, and each of these path nodes, the reason why we call them path nodes is where this is where our enemies are going to navigate. Okay, so this is how it's going to look. And it's going to fill this thing up with a bunch of these things. That's what this is going to be, right? I'm going to come back to this, where we're going to use this thing later on. But this idea is that's what these little path nodes are going to look like. And there are going to be 300 of these in the screen, just like there would have been last time. Instead of using a grid, we're going to use path nodes to navigate. Okay. So that's what these path nodes are. Path nodes are done. We've completed this part, and let's put this up on GitHub. So again, just like last time, we're going to say completed the path node class. Completed the path node class. All right, so commit to main and push. Nice and easy. All right, this place I'd like to ask, are you with me? Do you have the path node class? Do you have everything that we've asked you to do so far? How's it going? You don't have all of it. Okay, Braden, what's the thing that you're missing? Can you go back to the path node for 1 minute? Oh, I don't know, but 1 minute is like, whoohoo, that's a lot of time. Let's go back to pathnode.cpp. Is this the one you need? Is that the one? Remember that you always can get a lot of this online from GitHub. You go to GitHub. I'm always sharing this online with you, and GitHub has everything else that I've shown you. If that makes sense. All right, so let's move on. So this is the path node class we've completed, and let's get to the next part of what Alex has asked us to do. So we've got to this part. Okay, this is the big part, placing.h and placing.cpp. Wow, there's a lot of changes going on here. We're going to spend the majority of our time doing this part, okay, believe it or not. So, okay, let's start by, remember, this is part of the cleaning thing that we talked about before. We're going to start with placing.h. Placing.h, let's put that up. So placing.h, remember we talked about cleaning up everything. So what we want to do in our placing.h is remove all references to our tile stuff. So there's no more tile. Goodbye, tile. And instantly we have a bunch of areas here that we don't have. Let's add a reference to two things. We want a reference to a obstacle. So obstacle.h. And we also want to make a reference to our new path node class. Okay, so path nodes and obstacles, but no tiles. So really what we want to do is we want to modify this vector of tiles to a vector of path nodes. That's what we're going to change, right? So grid is now going to be a vector of path nodes. Okay, we're going to modify this in a second, the setup. So what we have here is, if we start off, let's clean this up a little bit. So we want to move this piece, is grid enabled, to up here. This is a grid enabled piece. And in our game objects, we have our spaceship, and that's pretty cool. we want to add in a bunch of obstacles, right? And then down over here, we're going to start doing stuff. Our path nodes, our grid of path nodes is going to be just above the build grid method, because that's going to be still our division scheme. But instead of a grid of tiles, our division scheme is going to be a grid of path nodes. We're not really dividing it necessarily, but we're using it as not only path finding, maybe, but more like navigation more than anything else. That's how we're going to move everything. Build grid is good, but get grid enabled, set grid enabled, compute tile cost, find shortest path, display path list, reset path finding, reset simulation, and all this stuff along with get tile, the heuristics, and moving ships, and all that stuff all the way down to the bottom is gone. Woohoo! All this stuff. Okay, so all of this stuff up to the build grid is goodbye. So that's gone, because we don't need any of that stuff anymore. I'm going to pause there when it comes to this part, and I want to start cleaning. This I did differently in the first half. I want to clean the playscene.cpp and remove stuff as much as possible, because we can have a lot of errors. And you can see that there's a ton of them. And I want to remove these ones from the beginning. So anything that we can obviously remove, we're going to do. Okay, so that all of this stuff, the Manhattan distance, the get tile goal, and the grid position, any grid position or any of that stuff, that's kind of really not going to happen anymore, right? There is no set grid position and get grid position. There shouldn't be a set and get grid position anymore from a navigation object perspective. We're not going to use grids. So these two things are gone. And we'd rather just start setting up the position of the ship. I just want to set up the position of the ship and the target right away. So remember, we took that away. So here, set transform position for the ship. I just want to move this to a GLM vec2 object that is 600 and 300. So that's kind of giving a position for the ship without anything else. So that is the target. Sorry. Let's do the same thing with the ship. I'll be okay. And we're just going to do the same thing. I'm just going to grab a GLM vec2 right here and replace this part with that part. And this is going to be about 150 and 300. Here we have our get tile status and all this other stuff that we had before. Compute tile costs we can remove from here, as well as all impassable tiles. That was the example from last week. We're going to remove all that so that we cleaned up our start. We also have a build grid. I want to keep the loop, but I want to get rid of all the stuff inside. So just like we'll start cleaning it up, because we're going to still have a build grid. And all this tile association stuff, our neighbor tile things, we're not going to have neighbor tiles in this division scheme, so we're going to get rid of all this. So again, our build grid is going to look pretty small, like this. So again, in our start method, all I've done is I've removed all references to tiles. In our build grid, we've removed anything from the double for loop. Okay, just cleaning. Anything that is red, any function that is red, I'm just going to get rid of it. So all these functions, I'm just going to start, kind of selecting. And all these functions that are red, that have nothing to do with us anymore, find shortest path and, all this kind of stuff, I'm just going to loop through really slowly and just go through all the way until I find functions that are red, right? And you're going to see that I'm just going to remove, by the way, it's also giving you a chance to do it, all the stuff that has to do with display lists and reset simulations and all that stuff. I'm going to remove the ship, and right here, get tile and set tile, special get stuff. The GUI function I don't want to remove, but all this stuff up to here, goodbye. That's gone. In my GUI function, right, it has a toggle grid, and I just want to hop to fix that problem right now. So again, all I'm doing is just removing and cleaning stuff to help us out later on with the stuff that we're going to be adding. All right, so our toggle grid function is still going to be around, but instead of us using a toggle grid, we're not going to do that. We're going to use the built-in is grid enabled. We're going to do that instead. So if our grid is enabled, then what I want is I want to call a function called toggle grid in here later on. We don't have a toggle grid function, but we will. We're just cleaning it off right now. Heuristic functions don't matter, so we're going to get rid of all this. Goodbye. The radio button for the heuristics doesn't matter, so we're going to get rid of that. Goodbye. The separator button for find shortest path, start and reset pathfinding. Goodbye. All those things are gone. Right? Same line for our reset simulation. That is gone. All right. And this part, which is our start position, the reason why this is all red is we removed the start position. This will be the ship position. Let's just do it. So we'll say a static int, which will be the ship position. Yep. And the ship position is going to be an array, but we don't care about the ship's grid position. I made that mistake earlier today. We care about the ship's get transform dot position dot x, and we want to initialize the ship position just like we had in the past. So this is just going back to what we had previous to this. So I'm going to grab all this and put it over here, and it's going to be dot y. Oops. So this is, I'm just cleaning up the IMGUI function. We don't need this line right here. And just down in here, we can get rid of all this, right? Inside of the ship position, we need to use the ship position as something we're going to look at from 0 to 800. Okay, we're not going to limit you. And inside of here, we want is m underscore spaceship, right? Get transform position, this part right here, right? And we want to say that that is equal to the ship position 0. Just like, remember we did this before in the original version, right? So this is the x. So x is 0 and y is 1, where we kind of move our ship around according to IMGUI controls. That's our ship. And similarly, our target properties are the same. This will be our target position. So static int target position. And the reason why this is glowing red is because, well, we've removed these references from our .h file, right? So again, m underscore p target get transform dot position dot x. That is going to be how we're going to use initializer syntax. And we're going to grab all of this piece and we're going to put that in there. Okay, so we're just cleaning. And we're going to use this target position instead of the goal position. We're going to go from 0 to 800, just like above. We're going to get rid of all this. Goodbye. And what we're going to do is grab these two lines and just copy paste. So target position is going to be instead of ship position. And instead of spaceship, we're going to have target. Okay, and this should say ship position and target position. So those are the two things. So ship property, target property. And these two things we don't need anymore. So we're going to get rid of those. Oof, wow, what a great cleaning we did. And it took away all of our errors. So all I've done, just to recap, right, is I've gone into the start scene. I've removed everything, given our target and our spaceship some basic positions, right? I've left build grid in there, but build grid doesn't do anything. It just loops through a couple of for loops right now. That's all it does. And I've cleaned up my IMGUI function by removing all the red and just redoing this part right here. Let's run this thing and see how bad things can get. Is it broken? And I want to run it in a couple places. Just I've cleaned the scene. I'm going to put this up as a separate commit. And yeah, that's what this thing looks like, right? There is no grid. If I toggle grid on and off, who cares? Because there's no grid. But I should be able to move this around now, and you should be able to do this anywhere you want. All right, let's put this up on GitHub, and I'll check if you guys are with me. So I'll say cleaned up, play scene. So that kind of satisfies one of our goals. And that play scene is gone. Play scene is cleaned up now. All right, going back to you. Are you with me? Have you cleaned up the play scene? Are you good? How are you feeling about that? I'm also going to check now on YouTube, and for anyone who's here. Okay, yeah, we've got people are good on YouTube. So far, so good. All right, couple people. What about the rest of you? Some people said no, or some people haven't really responded. Are the rest of you up to speed with me? I want to wait another second for you guys to get to this point. So I got a thumbs up from Braden. I got a couple of check marks from Tarif and Traver. I've got Erica that says okay. Ethan says, my IMGUI Y positions always reset to 0. Yeah, well, make sure that it's not get transform. It's not get grid position. It's get transform position. That was my mistake, Ethan. That's why it reset to 0. It was a copy paste error. Okay, so check that out and make sure that's correct. No problem. All right, I'm going to move on now. Hopefully we can move forward from here where we are right now. All right, so now that we've got this, let's continue with our playscene.h. We're going to add stuff now. So now that we've removed everything, we've cleaned up, we're going to add some game objects, and we're going to add some obstacles. So the first thing we're going to do is we're going to add an obstacle pointer, which we're going to call m_p obstacle 1. And we can add a bunch of them. Alex has gone ahead and suggested at least 3, which is kind of part of our requirements. I think we asked you for 4 or something like that in our assignment 3. And we've also going to add in a standard vector of obstacle pointers, which is going to be called m_p obstacles. Now, theoretically, you could get away without using these and just use the obstacle pointers. You just have to add them in one at a time. Here, I'm just going to go ahead and do what Alex did, just to make sure that people who followed his lab in the first half, or his lab and our lab are the same. That's why I want to do this. Okay, so, but this is pretty good. So what this does is it adds several obstacle references, and we're going to add these obstacles to the scene. Next, we have build grid, but we need a couple of additional utility functions, right? So one of them is void m_toggle grid. We kind of were saying that we're missing that. So bool state, that's going to help us with our IMGUI. We're also going to m_check ship line of sight. We're going to pass in a display object pointer, which is going to be the target object. And then we're going to m_store the object, the obstacles, right? Store obstacles is going to basically add all of the obstacles that are in the scene to the obstacles array. Again, going forward, we could probably optimize and remove that to some degree. And m_clear nodes, or maybe we'll just use that and not even have multiple obstacles. And then we'll have a static int, which is m_obstacle buffer. And Alex told me that I would love this part, and I do. I think it's awesome. And the reason why I love this is, so what is a buffer? First of all, let's talk about a buffer. Typically, a buffer is either an array of data of some kind, but sometimes we think about a buffer as a space between 2 objects. Think about it as a bubble, if you will. So let's go back to my little ugly drawing, right, where I have these things here. Let's just do this, and let's suppose that I have these things, and I want to add, I want to add 1. Let's just do one of these and just flatten everything, and try that again. Yay! Right, so I want to get all these ones. And bear with me while I do all this stuff, guys, so you understand what Alex has kind of thought of, which is a really great idea. So imagine if I have a grid of tiles, right? And I'm just going to make a grid kind of really quickly here, right? So here's, So here's our grid, right? And what I want to do with this grid is I want to use this grid later on next week, right? As a way of navigating from one tile or one position to the other position. That's what I want to do, okay? That's what these grid of tiles do, right? So imagine, or a grid of path nodes, I should say. So these grid of path nodes, if we think about this, right, we're going to be able to tell from one path node to the other, can I see the target? And why would I care about that as an example? Let's think about this for a second. Again, this is a pretty rough grid. All right, and let's add a couple of more columns in the grid. So again, I'm just drawing this out for you because I want you to understand why he's put this together, which again, I think is brilliant, right? So, but it's brilliant because it'll help us out next week with some of the stuff that we're going to ask you to do. So let's suppose this is your grid. So this is your scene, this is your grid, and this is pretty good an approximation of what it's like. I want to add in an obstacle, okay? So let's suppose here that the obstacle is going to be red. Right, so here's my obstacle. And what I want is I want obstacles of different sizes. Maybe I want an obstacle that goes like this, right? And maybe I have another obstacle that is on my grid that is much smaller, something that looks like this, right? And maybe there's an obstacle that somewhere else on my grid that is longer or wider. Well, what the ship is going to do, right? Let's suppose I have my ship object, and my ship, let's make it a different color, like black. Let's suppose my ship is here, right? So this is kind of my NCL. Doesn't matter where it is. Let's say my ship is here in between these obstacles, right? And it's trying to kind of meet the target, which is on the other side, right? The idea with line of sight is I should be able to cast a ray from one part of the screen to the other and determine if I have line of sight, right? So for now, what we're going to be doing is we're going to be casting a ray, and we're going to cast a ray from this ship all the way to the target, right? And if it passes through an obstacle like this, right, then it doesn't have line of sight. However, if my target wasn't there, but if my target was in front of the obstacle, let's say, for example, right here, so let's plot it right there, then obviously there's line of sight because nothing is blocking it. Similarly, what if I want if an enemy is trying to follow, if my player is trying to follow the enemy and the enemy gets hit, one of our requirements is for you to navigate behind line of sight. But I mean, look, can we really navigate across these tiles? Are these navigatable tiles? And the answer is no. We want to remove all the tiles that the obstacles sit on. That's the first thing we want to do. So we make a grid and remove the tiles that the obstacles kind of collide with. This is the first part. But going a step further, can I really pass by obstacles, as an example, or the path nodes that are very, very close to the obstacle? And the answer is no, because if I pass through a path node that's very close to an obstacle, I'm going to have a collision. So to promote collision avoidance, we're going to have another little invisible kind of area around each of the obstacles called the buffer. And anything outside of this area here is also going to be unwalkable or you can't traverse these nodes. And I've drawn these pretty close, but clearly what it would be is that if, let's suppose I had some kind of buffer, then the only place that I could traverse is maybe around here. See, because these ones are all, if I come too close, I'm going to intersect with the obstacle, no matter what I do. If I come this way, or if I go this way, I might hit this one or this one. So what Alex has done is he said, hey, listen, let's add a buffer, almost like a little bubble around my my obstacle to promote this idea of easy path traversal, right? As well as if I want to find a location, I want to traverse somewhere around an obstacle where I want to get behind cover. Let's suppose for my target, let's suppose this is my target, right? And my target, or I hit an enemy and the enemy moves behind cover. This is clearly behind cover, right? Because this path node has no line of sight with my player. It does not have line of sight, right? Because it passes through from this node to this node. And what we're going to be doing next week is we're going to not just look at the player having line of sight, but each node is going to basically say, does this have line of sight? 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 We're going to look at each of these things as they pass through. And if a path node does not have line of sight that is on the grid, right, then that's a viable place for our enemy to go to hide from the player. So this is why we're making this stuff. Again, it'll become more apparent to you as we go. Let me just undo some of these buffers and you'll see what I'm talking about in a second. So keep this in mind, this idea, because this is what we want to promote. Back to this. So now we have our obstacle buffer. That's what it is, a bubble that kind of passes around or surrounds our obstacle to give us a chance, a good navigatable kind of distance where we can kind of travel around the obstacle to avoid obstacle collisions or obstacle avoidance, if you will. All right, cool. So we've got everything we need here. Now we need to go to our play scene and we need to generate definitions by declaration. So we're going to add those in. Boom. That's it. Okay, so I've got my toggle grid, my check ship line of sight, store obstacles, and clear nodes. Okay. What I want to do here is I want to fix my toggle grid. That's kind of an easy one to do. And I'm going to do kind of one at a time as I get through this. Okay, so I'm going to go to the toggle grid. And then inside here, I'm going to say let's think about this. For each node, path node in my grid, m_p grid, for each path node, so path node, for every path node in my, there's no path nodes yet, but for every path node in my grid, what I want to do is I want to have my path node set my visibility to whatever the state is of my toggle grid. All right, so that is what this is going to be. We're just going to make this const, all right, to mark that on. That's going to happen. And what we want to do is let's go back over to, let's go to our GUI function and fill that in. So what we want to say is in the GUI function, let's think clearly here, what we're going to do. So in the GUI function is going to allow us to show the grid or hide the grid. And we're just going to say that, well, we are going to m_toggle grid to m_is grid enabled. So if the grid's enabled, we're going to turn it on. If it's disabled, it's going to be turned off. So that's the first function. All right, let's go back to the other functions that have not been created. All right, so the big one for me is build grid. I want to build the grid first before I add any obstacles. Let's get to that one. So go to build grid. And well, build grid is going to be different than what we did before, but there's going to be some really cool similarities because we kind of built the grid before, right? Let's think about build grid and what it's going to do. So first of all, at the top, we have our config tiles. We want to grab this offset. It doesn't really apply anymore in the start function. We're going to take that offset and put it down in here in the build grid. So we're just cleaning this up. In our start function, do we really want to build the grid up here now? Well, the answer is probably not. I probably want to set up my target and my spaceship and then only build the grid afterwards. So let's grab this build grid function and put it down before the play sound thing that we've got here. So I'm just going to reset up my start just a second to talk about how this is going to work. So this is where my build grid is going to be. I'm going to set up the grid afterwards. So this is set up the grid. And what I want to do with my grid is a couple of things, right? I want to say that by default, m_is grid enabled is going to be false. So we're not going to have that as starting off as true. Also, we have a little function called m_store obstacles. We don't have that in play yet because we don't have any obstacles to put in. So for now, I'm just going to comment it out and put a to-do in there. And to-dos kind of on the map basically show in blue. We can go back to that to-do and fill it up. So change that to-do. If you hover over, it says to-do m_obstacle, right? Toggle grid is where we're going to start off. We're going to start off with our toggling the grid. So to make sure that it is m_is grid enabled, I'm going to make sure it's off by default. So this is the change we're making to our start method for now. We just moved where we're going to do our build grid. And we're not storing obstacles because we don't have obstacles to store yet. We will. So I'm just going to show the, again, I'm just going to show the target and the spaceship with the grid first. That's what I want to do. All right, so how do we build the grid? So like we said, we just fixed it up, right? But we want to be able to fix up the grid. We have this stuff, the tile size, because we're going to have the same number of tiles as we did before. So tile size can be 40 by 40. What we want to do is we want to create 300 node path nodes, just like we did the tiles. That's not going to change. We definitely, when we come in here, just as an aside, we want to _clear nodes, right? That's what we want to do, which is basically going to, we need to clear them because we're going to, we will need to clear nodes because we will rebuild, right? Or redraw the grid, right? If we move an obstacle. If we move an obstacle, right? We need to redraw the grid because the obstacle, remember, just like we said, if the obstacle, if the obstacle is sitting here, we want to remove all these things. We want to remove this part of the grid, all right? So wherever the obstacle sits, there's not going to be path nodes because that makes sense, right? So we have to redraw, which means we have to clear the nodes. We don't have the clear nodes function working just yet, so we're going to use that as a to-do, okay? So that's something that we're going to do. All right, and then we're going to go through a bunch of, iterate through the grid of tiles. Instead of the grid of tiles, we're going to have a grid of path nodes. That's what we want, a grid of path nodes. And then after we do that, we're going to decide inside if we keep a path node or not. Okay, determine which path nodes to keep. Right, because if I have an obstacle on top of a path node, I don't want to keep that one. I don't want to even even show that one. And then after the for loop, right, this double for loop, I want to be able to, if my grid, is supposed to be hidden. Hey, he's done this for me. Make it so. This is a Captain Picard reference. I'm pretty positive, right? I think I know Alex enough to know that. So m_toggle grid m_is grid enabled. So we want to put that in. We know that works. All right, so again, I'm just scaffolding out the build grid method right now. Okay, let's continue. So we want to determine which path nodes to keep, but we need a temporary path node. So path node pointer, we're going to call this path node. And we're going to say that that is equal to a new path node. Okay. We're going to say that the path node get transform dot position, well, that's going to equal to a new GLM vec2 object. And how do we figure out that position? Remember, just like last time, we're going to take the column multiplied by the tile size, okay? And we're going to add an offset dot x, and we're going to do the same thing for the y, right? But instead of column, we're going to say that this is offset y, and instead of column, this is going to be row. So that is going to determine the position of the tile or the path. I keep on saying tile. The path node in the grid. Same as we did the tile. The tile and the path node are just, we're using them as an example as a different division scheme, a different way of traversing the entire grid. That's what we're doing. All right, we're going to start off and we're going to say that we're going to create a temporary Boolean, which we're going to call keep node. Let's make it keep _ node. We're going to say keep node is equal to true. And what we're going to do now is determine if we're going to keep them or not. Okay, so let's think about this. I'm pushing this down a little bit more. We're going to say for each, and for each m_p obstacles, we don't have any obstacles yet, but for each of them in the future, for every obstacle, right, that's what we're going to say, we're going to check a new collision manager function that Alex created, which is going to be called AAB check with buffer, right? Path node, the path node that we want to look at, the obstacle that we're looking through. Let's say, for example, I have 3 obstacles. For every obstacle, I'm going to take the path node that I'm currently on and the obstacle, and let's take a also look at the obstacle buffer. The obstacle buffer is going to start off at 0. let's say, for example, the obstacle buffer is 5 units or 10 units, right? I want to see that I have a collision between the path node and the obstacle. And if this is true, I'm going to get to that in a second. Then I want to say that keep node is equal to false, right? That means that I'm having a collision with the obstacle in that particular path node. Let's take a look at what he's done inside of AABB check. So what he's done for this one is he's taken the buffer. Let's take that buffer, right? And that buffer object that he's got is basically saying, hey, if my position 2 is we're adding buffers. We're basically saying that, hey, let's subtract the buffer away from p2.x and p2.y divided by 2. So whatever the amount of buffer is, we're going to reduce that. And the reason why we're doing that is because we are adding a buffer. Remember that little space around the obstacle. So we're saying that, just to explain, right? So if this is the obstacle, right, as an example, what we want to do is we want to add a buffer around it. So we're going to say, let's add a buffer. Let's make another color. The buffer is going to be around it like this, right? This is the buffer. It's going to be proportional to the obstacle, but it's going to be a distance of whatever the buffer distance is going to be divided by 2, right? That's what it's going to be. And that's going to add in the width and the height. And then that's how we're going to determine, right, if we have a collision. Because what's going to happen is, and we'll keep this in mind, that it's going to say, okay, if my object is colliding, if it's not already colliding, then what we want to do is we want to say that, okay, now it is colliding if it passes this check. We're still doing an AABB check, but we're modifying the P2 width and P2 height because we're adding in the buffer. That's what we're doing. So we're basically doing a rect collision detection check between the obstacle and each of the path nodes in the scene. All right. So now that we know that, that's what Alex has thought about. Again, brilliant idea for future work that we're going to be doing together, right? So think about this: AABB check with buffer. If it is colliding, then we don't want to keep that node. We want to remove it. However, right? And that's for each one. And that's what this part is. Determine which path nodes to keep, right? That's this part. And then after the for loop, we're going to say, okay, fine. If I'm keeping you, right? If I'm keeping you, then what am I going to do with you? Well, I want to add child. I want to add the node to the scene, right? And then further than that, let's add it to the grid. So push back the path node. Okay, that's what's happening there. What about if I don't keep you? Well, I need to do some cleanup because remember we created this path node pointer and we're going to have a dangling pointer from a memory leak perspective. That's not good. So we're going to say that we're going to delete the path node. Worst case scenario. We don't want to delete this path node because this path node here is going to be actually pushed back into the grid. So that's a good pointer. But this pointer here, which we created and we're not going to use, we're going to delete it. All right, cool. Again, is there optimization opportunities? Maybe. For now, don't worry about it. All right, so that is my path node that we're going to do. Let's set up clear nodes because that is it to do. I hate when I have to-dos. I just want to get rid of this to do first. So let's get this clear nodes thing done. Okay, that's what I want to do next. So clear nodes, let's jump to that. So am_clear nodes. Yay, there's clear nodes. Clear nodes is actually not that difficult to do, to think about. What do we want to do? We want to remove nodes, all the nodes in the scene, as an example. So there's a couple ways to do this. Alex has thought about using the display list. I think it's a great idea. m_p grid, right, .clear. This is one way of doing it, clearing it first and then going through all the objects in the display list that are path nodes and getting rid of them. That's what this does, right? So instead of getting rid of all the objects, let's just get rid of path nodes. So we're going to say for each, right? We're going to say for each, and we're going to use the display list. So get display list, get display list, and we're going to say for every display object, that's what it is, display object in the display list, for every display object in the display list, if display object, the get type, the type of the object, if that's equal to a path node, right, we want to get rid of it. We want to say that remove child. So remove child is another thing we can do where we can remove the display object from the scene. That's what this does. So again, a different way of doing it. I might have done it the other way around, where I go through the nodes and I remove each node from the grid. But why? Where we can just remove child. So the node is in the grid, but it's not inside the display list. So it's not being shown. So we're not removing it from necessarily from the grid directly. Here we're clearing the grid, so the grid has a 0 length, but we're actually going through and removing each of the children that we've just kind of added in. And I like the way this is done. So now we can kind of come back to this to do and undo it. Undo the to do. And so now the first thing we do is we go through, we clear everything. So we remove everything from the list, and then we build that list back up. If the list was already 0, then, when we do a for each loop, then there's nothing to remove. Okay. So for the first time we go through this, we add nodes to the list, just like we do normally. We check to see if we're going to keep them, if there is any obstacles. And if we're going to keep them, we add them and we push them back on the grid. Then we toggle the grid, whether it's on or off, as an example, depending on what the grid is. Again, what we could have done as an alternative is make each of the nodes we push onto the grid at the beginning invisible. It's really how you want to code this. This is fine too. All right, cool. So to me, m_build grid is ready to go, and we've triggered it up here. We don't have a store obstacles method, but let's see if we can just show the grid as is. So let's play it. Maybe we forgot something. Maybe we didn't. Let's see what happens. This is the first thing. So I want to build the grid. I want to see that grid with my ship and my target. Oh, hey, there's something we missed. What did we miss? What did we miss? Well, at the bottom, right, and this is what Alex kind of warned about. He said there's one external, which is at the bottom of our list. He kind of warned us about it. I just kind of didn't look and follow the instructions. It's my fault. We want to put on the bottom a place scene m_obstacle buffer, because we mentioned it as a static inside of our place scene.h, right? Remember we said this is a static, and every time we have a static, we have to basically declare it again. This is kind of a trick that we have to use inside of our CPP, or otherwise we'll have that weird error. Because it's static, but we haven't said anything to it, so this way is a way of going around that. Let's try that again and see what happens. So boom, and now we're ready to go. Hey, so we've got everything working, and if I go and toggle grid, bam, there's our grid. And that's what you should see too. Let's put this up on GitHub, and what we're going to say is we built the grid. So built grid of PathNodes. Commit to main and push. Okay, so are you with me? Do you have a grid of PathNodes that you can see? Let's go over to that build grid. So here's clear nodes, just in case you didn't get this. And here is your build grid. I'm just going to show you this. So if you're watching on YouTube, then you can go through here and add it in. Yes, I see a couple people. Braden's with me. Ethan's with me. Anyone else? How are we doing, guys? We're about halfway. Stanislav's good. Erica's good. Clear nodes, sure. Clear nodes is right here. Thank you, guys. Let me know when you're ready, Trevor. Okay, so thank you. So now that we have all this, we're ready to go. Notice there's these other underlines here, right? So underlines tell us there's some expressions that we can use. A lot of times they say flip the arguments, right? So it says do this. That doesn't make any sense to me. Just for a second, if this is equal to that, I mean it could, and the other one is negate. So if it's not this, right? I don't think negating it actually works properly, but it talks about this because it doesn't like this comparison. All right. It's recommending a different comparison. Let's leave it for now and we'll come back to this and we'll talk about it. All right. So now that we have this, we still have a couple of things to change. We have check shipped line of sight and store obstacles. Let's do the check shipped line of sight first. Can I have line of sight with no obstacles? I think it's a natural progression, right? So this takes a little bit of work, but let's think about how we're going to check line of sight. First, we start off with our spaceship. And we're going to say that the spaceship set has line of sight. We're going to say that by default, it starts off at false. So default, no line of sight. Okay, spaceship doesn't have line of sight. And then we want to kind of check to see if our ship to target distance, right, is less than or equal to line of sight distance, then we should check, right? If it's greater than that, why would we check, right? We're not going to check line of sight distance all the time. That's a waste of computational power. So let's do that. We'll say it auto ship to, and again, there's different ways of making this. I like this, ship to target distance. It's okay. I mean, we could, alternative, if you don't like this, if you want to go with what we've been doing so far, it'd be ship to target, target distance, but it's a little bit annoying to do it this way. It recommend it for me anyway. Ship to target distance is equal to a new util function, which is called get closest edge. This is kind of a neat thing. But we're going to take the m_p spaceship and we're going to get transform dot position, and we're going to check that with the target object. So what is the distance, the closest edge between the spaceship and the target object, right? So edge to edge is what, instead of like center to center. Okay, that's what this does. And I'm just going to skip through this right now and we'll explain that later. If ship to target distance, so that's what happens when you change stuff, is equal to m_p spaceship get line of sight distance. So whatever the line of sight distance is, in our case is 400 units for now. If our ship to target distance is less than or equal to the line of sight distance, well then we're in range, right? We are in range, right? And if we're in range, then we can do some checking. We can say that, okay, cool, let's make a standard vector, right, of display object pointers, which we're going to call our contact list. So, wow. When I saw this the first time, when Alex had done this with me, I was like, what did they recommend? Move variable to interscope, add const. Okay. I'm not moving that to interscope. When he first did this and I saw it, I was like, wait, this is perfect. Contact list, a list of contacts, not a contact like contact people, a list of things that are contacting with my ray. I'm casting a ray here, right? That's what I'm doing. And so again, going back to our thing here, imagine if I have a list of contacts. So I have a couple of additional obstacles, right? Let's say we have another obstacle, and the other obstacle is something like right here, let's suppose, right? And let's suppose I'm firing from this over here, and this is my target, let's suppose, is down here. Okay, so let's suppose this is my target here. So the contact list then, if I was going to cast a ray, right, would be from here, the edge to edge distance, right? And you can see that I'd have two contacts. I'd have this contact and this contact. Both of those things are intersecting with my ray. And what I want to do with this is I want to add those two obstacles to my contact list. So that's what I'm doing here. A contact list is an array of display objects, a managed array, which is a vector. All right, that's what I want to do. Again, brilliant. And again, for each, I want to talk about for each object in my get display list. Do that again. Display list for each display object, there it is, for each display object in my display list, right? What I want to do is if my display object's get type, if it's equal to a path node, do I really care? Right? Not really. So I want to really, ignore path nodes, right? Because we don't want to add path nodes to our display list. They're actual objects too. They're objects in my display list. Let's ignore path nodes. We don't care about those, right? And what about the other way? If what I'm really looking for, if objects are, if the object that I'm going through, if for each display object, if my display object is not, let's put it like this: if my display object get type, right? If it's not equal to my m_p spaceship get type, and why I'm doing this is because what if my spaceship is some other type? We don't know, right? But this is a kind of a good generic way of doing it. And let's suppose if my display object get type, if it's also that my display object get type is not equal to my target, we don't want it to be a ship or a target, right? So both of those things are not what we want, target object, right? So if it's not one of those, it's got to be my obstacles. Now you may ask, why not just simply say obstacle? Okay, but what about if there's other things we want to check inside of our display list? What if it's the obstacle and if it's other enemies? That enemy would block, as an example, line of sight, right? Or what if it's something else in the future for your game, right? You don't want to specify. We want to specify. We don't ever want to look at spaceships or targets as something that we want to check in the display list. We only care about those other ones, but it could be other objects we don't care about right now. We don't have them in our game, but we might have them in the future. So we're going to check if the object, the display object, is closer to the spaceship than the target. Okay, and if that's true, we know we have no line of sight. So here's an example. If this is the target and this is the, if this is the spaceship, so let's color this, this is green, this is the spaceship, this is the target. So this is the spaceship. And this is the target. And this scenario, right? We clearly do not have line of sight, right? Because these two objects are closer to the spaceship than the target is. If the target was closer to the spaceship and we were connecting with it, then these two targets would not be in our contact list. We don't care about them, right? We only care about these two objects if the target, as an example, is further away than with a couple of contacts, the contacts that are in the list. Does that make sense? Objects that are, if my target is farther away than obstacles that I'm colliding with my ray, I don't have line of sight. That's what it means. All right, so that's what we're checking. So we're checking that. So we're going to say auto, and we're going to do the same thing, ship to object distance, right, is equal to a util, and then get closest edge. Love that function. m_p spaceship and get transform dot position, right? And the object that I'm checking, which is my display object. So if the ship to display object distance, right? If my ship to display object distance, ship to object distance, right? If that is less than or equal to, right? If it's closer to me than my ship to target distance, right? If it's, so the object, the obstacle is closer than the target, that's what this means, then we do not have line of sight and we want to add our obstacle, right, to the contact list. Okay. Does that make sense? So that's how we really determine line of sight. We determine line of sight by saying, you know what, this obstacle is closer to us. Imagine it in real life, right? If I have something in front of me, I'm looking at something, right? Line of sight. I'm looking at something and something comes in between one thing that I'm looking at and my eyes, right? Well, I can't see that other object. It's obscured, right? So that's what's happening here. So we add it to the contact list. Cool. Okay, great. So if we add it to the contact list, we're going to say that let's determine line of sight now. So has line of sight, right? We're going to say that, we'll say line of sight like this. Has line of sight. We're going to use the collision manager for this. Hey, collision manager, we're going to do a line of sight check where we're going to start off. Remember, line of sight check has the agent, M_P spaceship. Here's our spaceship. M_P spaceship with what? The endpoint. So the start point and the endpoint. What's the endpoint that I'm looking at? Well, that is my spaceship transform position. Let's put this on the next line. So M_P spaceship dot transform dot position, and we're going to calculate how far we can see by the M_P spaceship dot get current direction. This is the place we're looking, the direction we're looking. That's a vector, direction vector, multiplied by my spaceship. And this is kind of similar to how we drew it, get line of sight distance. So that's the endpoint. Then I want to look at which is next. And this is brilliant that, again, this is a, Alex has overloaded the line of sight check in the utility function, right? The collision manager function, where we pass in the contact list. So this is contact list, right? We pass in the contact list, and of course, we're going to check the contact list with the target object. So this little thing is going to basically create, do I have line of sight with all my contacts? Is my target object closer? Is my target object closer to me than my contact list? If it is, then I have line of sight. If it isn't, I have a bunch of stuff in my contact list and my target object is farther away, then I don't have line of sight. That's how it's going to determine line of sight. And this is going to say, make this, it's probably going to say, oh, rename to has line of sight. Doesn't like that. That's fine. And then I'm going to say M_P spaceship, right? And we'll say set has line of sight to has line of sight. Again, we could have put all of this inside of here, but it doesn't make sense. It's too long. Even this is pretty long. We could have probably broken this down even more too. All right, so this is pretty good. This is really great, right? Now, why is this flashing like this? Well, it's saying that make the function const. I don't mind that, right? Because making the function const, right, is something that can help. It's still flashing. It's saying this. It's saying, and this is like just, this is it. Make the function const, right? But if we make the function const, does that have any negative effects? All we're doing is checking ship line of sight. We're returning something out. What we're returning here is we're returning void, and so there's nothing for us to return. So if we make it const, who cares, right? That's the first thing we're doing. Again, it's checking some of the names. So move to inner scope. We don't care about that. And let's look at this one. Again, it says move to inner scope. Add that as const. That's what's happening there. It's just making it const, making it type safe, right? That's what it's doing here. Right? And what is this going to be? It's probably going to make that const, saying, hey, make that, okay. Make that const. I'm just going to move this over so you can see it. There we go. Actually, we'll just do one of these. Whoop. There we go. And that's where this one should be too. All right. So that is what's happening there. It's telling me to do some stuff. I've just done it. And again, we can always look at any one of these things, and ReSharper sometimes helps us make things a little bit more efficient than what we had before. All right, let's check it out and see if we actually can determine if everything is good. So save and run, and does it break? Did we break something? I always want to check in between to make sure we didn't break anything. And I don't think so, but let's see. Okay, so there's our ship. And if we move the ship closer, then we should see that we have line of sight. Okay, so that is clearly not working, right? If it was, if we had line of sight, then this should be detecting right now, right? Look at that. So that is what this does. Well, of course, did we actually call the check ship line of sight anywhere? Well, that is something we need to do. If we don't call it, we're not going to be able to use it. So up in the update function. So again, maybe we had the update function up here. We want to check that. We want to say that m underscore check ship line of sight with m underscore p target. Okay. So that's going to happen every frame. Let's try it again. Didn't break, but we didn't do what we wanted either. All right, cool. So there's no line of sight, but if we move the ship closer, then boop, just like that, we have line of sight. All right, it's a way of checking to see how this works. All right, nice. Great. So our line of sight function works. Let's put this up on GitHub. So again, at least so far. So far it looks. So we're going to say something like added check ship line of sight utility function. Okay. And we're going to push that to origin. But we don't know if this exactly works yet until we have some obstacles. I guess that's the next step. Next step is let's put some obstacles in play. All right, let's go back down to here. So now this is the time where we can add some obstacles. And what Alex has done for us is he's kind of created a few obstacles that we can add. Let's add in one obstacle at a time, and let's see how his stuff works, which is pretty cool. So again, we're going to say m underscore p obstacle 1. That's going to be equal to a new obstacle object. And what we want to do is we want to add that obstacle object in, m underscore p obstacle 1. Awesome. But we also want to give it a position. So we're going to say that, okay, let's put that in. So we're going to say m underscore p obstacle 1 dot get transform dot position is going to be a new GLM object, a new vector. And where do we want to put this? Let's start it at 380 on the x-axis and something like 80, so kind of at the top part of the screen on the y-axis. And let's just add it in as is and see what it does. Now, in order for us to make this the grid disappear, we need to fix up this store obstacles thing. We never had obstacles before, but this is a great time to do that. So let's move into that part. M underscore store obstacles. So store obstacles, as an example, we want this to be a thing, right? But so how would we do this? It's kind of the same thing as we've done before. So again, we're going to look at that display list again. In fact, I want to grab this whole thing here from the clear nodes and kind of copy paste it in here. And what we're actually searching for is if my display object type is an obstacle this time, not a path node. I don't want to remove child. That's not what I want to do here, but rather I want to push this. So m underscore p obstacles dot push back the display object. That's what I want to do. But the problem is, okay, so here's where we're getting an error. Display object is not an obstacle. Display object is a kind of a higher level, it's a higher level, higher up on the class hierarchy. And it doesn't give us, it sometimes, ReSharper doesn't know what to do, right? It's not going to sit there and say, we have this issue, kind of thing. It's not going to tell us what to do here. We need to cast this, static cast this as an obstacle. So again, we're going to go static cast as an obstacle pointer, this display object. That's what we want. And now it works, right? Because we know that obstacle is an agent, obstacle is a display object, but we want to be able to static cast this as a display object. And it's giving me some, it's kind of crying out. It says replace static cast with dynamic cast. And I think it needs that because, yes, because we're downcasting. Okay, cool. So that is this. Display cast, the dynamic cast or the static cast will work, but it's recommending dynamic cast because we're downcasting. All right, so cool. So and once this is done, m_store obstacles. Well, that's okay. Now we can re-enable that in our start method. So if I go back to my start, then where we had our to do, we can get rid of that and actually call store obstacles, because now we have an obstacle to store. Actually, just for briefly, let's not do that and show you the difference. So let's run this and let's see that one obstacle. Here's the obstacle. If I toggle the grid, you can see that the grid passes through it all, right? We don't want these path nodes in the grid at all. We don't want these, okay? And in fact, if we move up our ship, we should be able to check already the line of sight works. Notice that there's no line of sight here, right? But if I move my ship down or my obstacle over, as soon as or my target, I'm saying if I move my target over here and it's closer to my ship than the obstacle, we have line of sight. So this is further, proving out that line of sight is working. But we don't want these ugly path nodes in here, right? We want to remove the path nodes if the obstacle sits on top of them. And that's what this function, store obstacles, will allow us to do, because it adds obstacles, each of the obstacles to the obstacles vector. And in the build grid, remember we went through here and saying, hey, check through the obstacles for every obstacle in the obstacles vector, check to see if we have a collision with the path node, and if we do, don't keep it, remove, don't even put that, don't even make that as part of the list. So if I do it now, once I've enabled the that little function, you can see that when I toggle the grid, path nodes do not intersect with my my obstacle. Okay, so that's the kind of thing that we want to do. So wonderful, we've added an obstacle. Let's add the next ones. I want to add all of them, right, to the scene. So let's add all 3. And also one more thing, if we change the size of my obstacle, right? So let's say, for example, if I go to my obstacle 1 and I want to change the width or the height, let's say m_p obstacle 1, and I want to change the, set, let's say set height. Let's say the set height, we want to make it 50. So it's going to change the height of the obstacle. And if I did that, you can see now that the obstacle will dynamically change size. So it'll be scrunched up like this. And if I go show the grid again, you can see that there are no path nodes are kind of intersecting with it. Now we have a bit of a space here. Well, that's okay. But again, we could probably pass along this way, but these are too close. And that's why we're going to, we're going to enable IMGUI to add a buffer. All right, cool. So that is our first obstacle. Let's add a couple more. I'm just going to copy paste here. Okay, so let's say our last obstacle we'll keep as is. We'll keep them all at 380. The second one we'll put at 280. And the last one we'll put at 480. That's the positions of the obstacles. The second one, instead of set height, we'll make it wider. We'll set the width. We'll set the width to 100. That's the values that Alex recommended, and I'm going to stay with those. So those are 3 obstacles now. Let's see. Oh yeah, this is the same obstacle. Let's make sure it's a different obstacle. Woohoo, that would be bad. There's 3 obstacles. 1, 2, 3, right? And then what I can do is I can run it, and we should see 3 different obstacles here, right, of different sizes. And if I go back to the grid and run it, you can see that the grid does not intersect with the obstacles in any place. Okay, and we can also check to see if we have line of sight with every one of the obstacles. So again, if I go to here and if I move this there, you can see that that has line of sight, but when I'm behind the obstacle, no line of sight. Wonderful. That's great. So we've added obstacles, and we're pretty much almost there now in terms of everything except from some functions in IMGUI. Let's put this up on GitHub. So we're going to say added obstacles to the scene. I had a great suggestion today as well from one of our students. David said, hey, why don't we randomly generate obstacles, random places and random sizes, as an example. That might be a really cool exercise. We can have little obstacles, bigger obstacles, and randomly spaced throughout the entire scene. I think that's a great idea. It creates additional challenges, but this is pretty cool. So now the next part is let's add some controls so that way when I run my game, I can do a diagonal kind of cut with my line of sight, similar to what we've drawn here. So what if I want to change my angle of my ship? Instead of looking this way, I want to make it look down that way. We can add some controls to IMGUI to enable this. All right, so let's do that now. And then I'll check to see if you guys are all good. So in IMGUI, let's go to that function. Here's the GUI function. Let's change this to lab 6. How about that? Instead of lab 4. Totally forgot. And let's take away some spaces just to clean up a little bit. So right here underneath the toggle grid, I have my spaceship, my ship position, and then between my ship position and my target, it's still a ship property. Still a ship property. What I want to do is I want to add a static int angle. And what I want to say is if my IMGUI, and I want to make a slider int, here's my slider int, which we're going to call the ship direction, right? And we're going to pass in the angle that we're going to take in. We're going to start off at minus negative 360 to 360, right? That's where it's going to be. We're going to start off at 0, actually. And we're going to say that m_p spaceship dot set current heading gives you an angle of whatever that angle is. So that is the angle of rotation. So we're going to allow the ship to rotate. Okay, so it's going to be. And let's try that out. So one little piece at a time. So again, we have our rotation. We can do one of these now. Okay, so it rotates along with my my object. So again, if I was to do something like this and bring it further up, and if I just to test it out again, let's bring our target here and here. We can clearly see that there's no line of sight, right? However, if I'm down in here, right, and we kind of angle bring it further down, right? Notice that it's just touching the edge, still no line of sight. But as soon as I move my ship down just a touch, right? So this way. Now, okay, you see how this is not quite perfect because we're using a rect here instead of a circle. That's why this is giving me a line of sight when really visually we don't have line of sight because we're using a rect collision detection. Later on, we'll change this to rect circle as well. All right, so that's pretty cool, and that is rotation. What else can we add to IMGUI? Well, I'm also going to add in, let's add a separator. So there's a separator between my my target, my ship position, as an example, and my and between my ship direction and my target direction, my target position. Let's add a separator between these two things. These are kind of together, right? Again, if we want to try, we can put this on the same line, but I don't think it's a good idea, right? But the separator between the separator and the target position, let's put another separator after the target position, right? And what we want to do here is for the next one, I want to add in obstacles. So this is kind of an interesting way of doing it as well. So kind of add obstacle, kind of position control, right? For all obstacles. So I don't want to do it one at a time. I could say like, okay, so just like we did up here, right? for the ship, I can say, obstacle 1 position, obstacle 2 position, obstacle, that's crazy, right? Instead, we'll run a little for loop, and IMGUI supports this, where I want to do for I, and I want to say for I is, and we want to use an unsigned I. Okay, for I is equal to 0 to the number of obstacles in the obstacles list. So p obstacles dot size. So for the number of size in the obstacles, I want to kind of do the same thing that we've done before. I can just actually copy all this for a second, and I want to modify some of this stuff down in here. So what I want to say is, instead of target position, let's call this obstacle position. Obstacle position, right? And we're going to say that the obstacles array, and we're going to look at for this obstacle, right? For this obstacle, get transform position on the X, and for this obstacle, the first one, get transform position on the Y. We're going to set that to the obstacle position array, just like we did up here. All I did was copy this over here. And this will be the obstacle. Now again, in order for me to make the proper string, let's make a standard string, which we're going to call this the label. And we're going to say that the label is going to start with obstacle, right? Plus the number, obstacle 1, 2, 3, standard, right? ToString. We're going to cast ToString the index plus 1. So in other words, we're going to, instead of counting at 0, 1, 2, 3, we're going to start at 1, 2, whatever it's going to be. 0, 1, 2. We're going to start at 1 instead of 0. Okay, so plus position. That's what this is going to be. So that's going to kind of form up my label. And I want to take that label and replace it here. So this is going to be the label. But we can't just put a label, even though it's a string. IMGUI is a C library, so it's C string. We're going to convert it to C string. And then instead of the target position, we want to take this obstacle position, put it there. And it's going to be from 0 to 800. That's all the same. And then we replace target with obstacles I. Okay. And instead of target position, we use obstacle position. There we go. And that is good. But then when we do that, when we move the obstacle around, remember we want to remove places in the grid, the path nodes that the obstacles collide with. So we're going to rebuild the grid every single time. And that is going to also clear the nodes first, just like we said earlier. So that little piece right there is the piece that's going to reposition our obstacles anywhere on the screen. And that's for every obstacle, we're going to have another little slider int. Okay, let's try this out and see what happens with that one. So look at all these sliders. Nice, nice, right? But we have a problem. It didn't kind of select these things correctly. It's all 380 and 80. Oh, man. Why? Well, remember what we're doing. We're saying our obstacle position is a static value, right? We don't want to make it a static value in this case. Okay, we don't want to make this a static value because if we made it static, then it would be the same every single time. Let's try that again. So now we can see that they're all different. And if I move this one around, let's put the grid on, and if I move the middle one around, you can see that the grid redraws itself, right? So we can kind of position it kind of halfway through, right? Like so. And we can move the other one around too. Okay. And we can move this one down. So we can make kind of like a little area where the ship has to go through to get to the target. Okay, and one check that we want to use is we want to kind of reposition our ship to the new position of the obstacle to make sure that we still have no line of sight when the target, as an example, is behind the obstacle, even when after we moved it. Okay, works. All right, so this is great. This is our changing obstacle position. So we did two things. We changed the rotation of the ship, allowed the ship to be rotated. And the second thing is add control for all obstacles to move as well. Last thing we're going to do, right, is we're going to allow us to change the buffer. So let's add another separator. And what we're going to do is we're going to say if I am GUI, and if I am GUI slider int, we're going to call this the obstacle buffer, right? And the obstacle buffer is going to need we already have this, right here. Look, obstacle buffer, m_obstacle buffer. We're going to start off from 0 to 100 units. Then what we want to say is that as soon as that changes, rebuild the grid. Okay, so why? Remember that the obstacle buffer, when we build the grid, is going to be something where we determine the bigger the obstacle buffer, the more path nodes we're going to remove, right? Like we talked about, back to my drawing, this is the obstacle. And if we draw the obstacle buffer, let's layer it down. If we draw the obstacle buffer around it, so around each obstacle, and we say some units around, let's say, for example, it's enough that it collides with all these nodes, then all these nodes will be removed too, right? And it really depends. Each obstacle buffer is the same size, right? But we could make it so that in a future iteration, that this obstacle buffer could be smaller, right? Or irregularly shaped. It's really up to you, okay? But the idea here is that the obstacle buffer will remove additional, additional path nodes because these are unwalkable. They're too close for the player or the other objects to go around. That's what the idea is here. So that's what we do here. The obstacle buffer in IMGUI, if we make it bigger, closer to 100, it's going to wipe away more path nodes, right? Which is a great idea again. So going back to that, let's just take a look at that build grid one more time, right? So here's build grid, and this is where it happens. So first we clear our nodes, that's what we're doing here, and then we loop through to create the grid, but we do this little check. We say, hey, am I colliding? Is this path node colliding with an obstacle? Yes or no? And let's add more space around the obstacle's width and height, create almost like a different collision rect, right? So AABB check with buffer checks the AABB, the rectangle of the path node, which is 10 by 10, with the obstacle for each path node. It adds buffer to the obstacle, whatever that buffer value is. Okay, so what this means is kind of like that in Unity, yes. So Ethan says, so it's like changing the nav mesh radius. It totally is. It's exactly what we're kind of trying to do, right? And so if we do that now, let's take a look. So right now the obstacle buffer is 0, and you can see that it's the exact same. But if we increase this value, this is where it becomes really interesting to see. You can see that more path nodes start disappearing around our objects because we can't navigate so close to them. So we keep doing that, and you can see as we increase the size of the buffer, more and more path nodes go away. And looks like to me like this is 55 or thereabouts would probably be, or 54 or 55 might be the right value for you to have to go around these obstacles with no chance of you colliding with them in this particular setup, right? But if we move the obstacles around, do we keep this value? What happens? You can see that, yeah, it does, right? So if we move closer, it kind of wipes away some of those areas. So we can see that it still won't collide, right? And same thing goes with the middle one. Let's move the middle one around, right? Let's move it up a little bit. And you can see that here, it's clear that there's no way you'd pass through this area here. It's too dense, right? These two obstacles are too close to each other. So most likely this thing will take a path around these obstacles because these ones are so close. And that's a great idea to remove path nodes, walking nodes around the obstacles. Okay, so that's why it does that. And that is the final thing we want to do. So let's put this up on GitHub. So we'll say modified IAM-GUI to add additional, to include, we'll say, additional controls. Obstacle controls. Right? And push. All right, that's it. Questions? Any issues with any of the stuff that we've done today? So again, just going back to that stuff with the IAM-GUI function. So the IAM-GUI function, we did toggle grid, we did that. We changed the ship position and we added angles. We can rotate the ship so we can point at different things to make it more interesting. We've added in a for loop to kind of add control to move each obstacle. So basically, like this is like for each obstacle in obstacles. That's what we're doing here. We're looping through, and for each one of them, we're adding its own set of controls. And this is kind of neat that we can do this with IAM-GUI. It's dynamically creating them. And then finally, we're adding an obstacle buffer that allows us to create a space or a bubble around the obstacles to wipe out stuff. Wipe out the path nodes. All right, one last thing to look at always is let's take a look before. I know we're running kind of a little bit over time. Bear with me. Let's take a look at the steps to make sure that we've got everything. All right. So again, the lab report won't be up until next week where we have all the details. Okay. So we were kind of fooling around here. We did the include path node and obstacles, removed include for the tile, removed all members from the pathfinding. We did that, added 3 new obstacle members in the vector of obstacle pointers, right? We added modified members for a new grid of path nodes. We did all that. We made a couple of commits here in different order than Alex did, but that's okay. Don't forget to define the obstacle buffer. I forgot, right? And we figured that out, that it caused an error, but I fixed that. We modified the update to include line of sight. We did that after. Modified start to unlock game objects from the old grid. We did that a lot earlier. We set up new obstacles and a new grid. We did that. Removed pathfinding from IAM-GUI. We did all that. Filled in helper functions. We did it in different order, but one option at a time. Filled in functions to build and toggle the grid. We did all that stuff. We build grid is invoked frequently, so any path nodes out of the movable objects are deleted. We just showed that. And add method to check ship line of sight will be modified next time for all agents, where we kind of make a detection from each path node or from each agent to the target. Okay, and then our to do for part 2 after line of sight again, so it can be used for the path nodes. We're going to determine which path nodes have line of sight to the target. It's almost like we're going to raycast from every path node to the target, which is kind of neat. And then we're going to create a shortest path around obstacles from the ship to the target using path nodes and line of sight, which is very, very cool and interesting. So that's it for this week, guys. Hopefully that helped you. And again, it's recorded online just in case you missed something. Any questions before we go for the day? Okay, guys, thank you so much, and see you next week. Thank you. I'll stop recording this on YouTube. And I'll say thanks. Alex was actually watching, so I'll say thanks for all your help. There we go. All right.